Let's look at a few more examples on simplifying some expressions in such a way that there aren't any fractions in the answer. All right. Um, so we're going to go ahead and simplify this. Notice that 5 is okay because there's no value in the denominator. There's 5 is going to stay in the numerator. I have x to the 6 over x to the 8th. So I have 6 minus 8, which is a negative 2. So that means I have 2 in the denominator, so x squared. And then 2 minus 1, because don't forget there actually is a 1 there for the exponent, is 1. So I just get 5, or y, sorry, left there. If there's no fractions in my answer, technically I'm going to have to rewrite this so that x squared is in the numerator. But if I'm changing that location, I've got to make the exponent opposite of what it was. So because it was positive in the denominator, it's going to be negative in the numerator. So I am going to have 5x to the negative 2 power times y, because there are not any fractions present in that answer. For my next one here, I'm going to go ahead and simplify this first. So looking at my numerator, I get 3 times 4, which is 12. And I'm going to add my exponents on the x there to get 3 plus 4 is 7. And in the denominator, I got to square both the 2 and the y, so I get 4y squared. So upon further investigation, 12 divided by 4 is 3. X to the 7th over just y squared. But if we want to write this so there are no fractions, we have 3x to the 7th, y to the negative 2 power, because we have to put y squared in the numerator, which means its exponent is going to turn negative. The last one we're going to look at here, again, I'm just going to start by simplifying. So I'm going to look at my x's to begin with, and I'm going to subtract those. So 1/2 minus 3/2. 1 minus 3 is a negative 2 over 2. So really, I get x to the negative 1 power. And then y, let's see what I get here. So 5/2 minus 3/2. And that's a positive 1. So I just get y to the first power. So x to the negative 1, y to the positive 1 power.